Hello everyone, welcome back to this online class. Today we are going to look at Runge-Kutta method, and in particular we are going to look at a case where you are given a Butcher table and you are asked to use that table to solve an initial value problem. Now we have this question. Consider the following Butcher table. We have the table as you can see. Apply the above methods to the initial value problem given by dy over dx is equals to x times x squared minus y squared. And the initial condition is that y when y at 1 is equals to 0, use step size of h is equals to 0.5 and compute the value of y of 2. So let me tell you how to interpret this table to be able to obtain the values of k1, k2, all the way up to k4, and also the value of k. So from the given table, on the left side of the vertical column, those are the coefficients of h. So those are the coefficients of h. On the right-hand side, the first column are the coefficients of k1. Second column are the coefficients of k2. Third column, that is k3. And then now, when you look at these values here, those are the coefficients of k1, k2, k3 when you are calculating the k. The blank spaces means zeros, so you can insert them. Here we have 0, another 0. Again, we have 0, 0 in that order. Those are zeros, which you don't need to write. So then it means that the iterative formula based on that Butcher table, iterative formula from, or simply based on the given table. That table is Butcher table. So we start with K1. It is K1 is equals to H f of xn. But you see, we are adding 0h plus 0h. That's what it means, comma, yn plus k1, we are adding 0, so it's like 0k1 plus the other 0 is 0k2 plus this other one is 0k3, which simply means that this is equals to h times f of xn yn. That's what it means. Let's go to the second row. That will give us K2 now. K2 is equals to h f of xn plus, what are we adding? 1 over 2 times h. 1 over 2h. Then yn, this other 1 over 2 is the coefficient of k1, so plus 1 over 2 k1 plus 0k2 plus the other one is 0k3, which when you simplify will give you h f of xn plus h over 2, comma, yn plus k1 over 2. The other row is the third row. That will help us find k3. So we proceed. K3 is equals to h times f of xn plus What is the coefficient of h? That is 1 over 2. 1 over 2h, comma, yn plus, here we have 0k1, so write 0k1 plus, the other one is 1 over 2k2 plus the other one is 0k3. If I simplify this, we are going to get h f of xn plus h over 2, comma, yn plus k2 over 2. And finally, the fourth row, that will give us k4 is equals to h f of xn plus, what are we adding? It is 1 h, 1 times h, comma, then yn plus, this is negative 2k1, so negative 2k1, followed by 9 over 4k2 over 4k2, followed by 3 over 4 k3. And when you simplify this, it's just the same as what we have there. So this simply equal to h f of xn plus h, comma, yn minus 2k1 plus 9 over 4 k2 plus 3 over 4 k3. Having found k1 all the way up to k4, we still remain with the fifth row. Those will help us find the values of k. So from the fifth row, we'll have k is equals to, of course there's no h, so we start with 2 over 5 k1, 2 over 5 k1 plus, the next is 0, so plus 0 k2 plus the next one is 1 over 5 k3, 1 over 5 k3, and this other value is for k4, 2 over 5 k4. If I simplify this one, it is the same as 1 over 5 outside. Inside we'll have 2k1 plus k3 plus 2k4. That is how to interpret the Butcher table that is given there. And remember, I didn't write k4, so there's k4 here, and everything is 0. So even when you are adding, there will be 0 k4 everywhere, which does not even change our formula. So having interpreted the Butcher table, remember for you to get y is the same as, of course, it is y sub n plus 1 is equals to yn plus k. So what you realize that the Butcher table will help you find the k values, k, k1, k2, all the way up to k4. Once you have them, you simply replace here and get your corresponding y values. So you say where n is equals to 0, 1, 2, 3, etc. But from the given problem, look at our ODE. Let me take you back. If you look at our initial conditions, of course, this is our x naught, which is 1, and the 0 here is our y naught. This function here is our f of xy. So this is f of xy. And we know the step size h is equals to 0.5. Now we need to find the value of y when x is 2. So let me summarize those here. So you say we are given that x naught is equals to 1, y naught is equals to 0, h is equals to 0.5, and our f of xy is equals to x into x squared minus y squared. So what we need to find is this. You can draw this line, this kind of a line, so that our x naught is 1. So we're starting from 1. Step size of 0.5. So the next is 1.5 because h is 0.5. Then lastly we go to 2. So this is x naught, x1, x2. What is the corresponding value of y? Y naught is 0. I don't know y1, neither do I know y2. So here we have y naught. I don't know the value here, that is y1. Neither do I know the value here, that is y2. So when you write y1, it is the same as y at x1. And that is the value of y when x is 0 is 1.5. 1.5. Remember, we don't know that. We are going to calculate it. So I'll put a question mark. And when I write y2, it's the same as y at x2. And that is the value of y when x is 2. I also don't know the value here. We need to calculate it. So now let's start the iterations. We use n0, then proceed to n1. We just need 2 iterations because we need y1 and y2. So the starting point is when n is 0. So you write put n is equals to 0. That will give us y1 is equals to y naught plus k. So we can find k1. K1 is equals to h, f of x naught, y naught, and based on the definition of our f of xy, we'll have h times, remember, let me take you back and illustrate what we're supposed to do here. F of xy. So from here, if you want to find f of x n y n, it will be given by f, I can use another color, f of xn yn. That is the same as xn times xn squared minus yn squared. Simply where you have x, you put xn. Where you have y, you put yn. Even if you have f of xn minus plus h, then yn may be plus another value. You just do the substitutions. You change those parameters. So like here, we'll now have x naught into x naught squared minus y naught squared. And so h is 0.5, x naught, that was 1, into 1 squared, y naught is 0, we square it, and that should give us 0.5. Let's compute K2. From our formula, it is h f of x naught plus h over 2 y naught plus k1 over 2. And so this will be h into Now, our definition of f of x, y is x into x squared minus y squared. So where there is x, we put x naught plus h over 2. And where there is y, we put y naught plus k1 over 2. So it will be x naught plus h over 2. This should multiply x naught plus h over 2, and this is squared, minus y naught plus k1 over 2. Again, this is squared. So when you do the substitutions, because I don't need to write the values of x naught, we have them already. When we talk of x naught, you write 1. Y naught, we have the value already. K1, we have the value, and even h. So you substitute and press in your calculator. You need to get 0.9375. 9375. Let's compute K3. So K3 should give us h f of x naught plus h over 2, comma, y naught plus k2 over 2. And this is h. Our f of xy is x into x squared minus y squared. So where there is x, you put x naught plus h over 2. Where there is y, you put y naught plus k2 over 2. So this should now give us x naught plus h over 2 times another x naught plus h over 2. Now this is squared, minus y naught plus k2 over 2 squared. When you substitute those values and you press in your calculator, you need to get K3 is equals to 0.839233. 839233. And finally, K4. Based on our definition for K4 is h, f of x naught plus h, y naught minus 2k1 plus 9 over 4 k2 plus 3 over 4 k3. And so this equals to h into x naught plus h times x naught plus h, and this is squared, minus y naught minus 2k1 plus 9 over 4 k2 plus 3 over 4 k3, and this is squared. When you press in your calculator, you need to get K4 is equals to negative 0.580069. 0.580069. So therefore, our K we said is the same as 1 over 5 into 2K1, and our K1 is 0.5, plus K3, which is 0.8393, and that is 9233, plus twice of K4, which is negative 0.580069. When you work it out, you need to get 0.135819. 135819. And so you can now get y1, which is equals to y0. Y0 is 0 plus k, which is 0.135819. And so this is the same value, 0.135819. So this is the value of y when x is equals to 0 point, not 0, but 1.5. So let me bracket it and comment on this, that this is the value of y when x is 1.5. So we have found the first one. We have found this value as 0.135819. So we still need y2. Let's perform another iteration with n is equals to 1 now. The same procedure. So you write put n is equals to 1. Put n is equals to 1. With this, we need to get now y2 is equals to y1 plus k. Compute the new values of k1 up to k4 and also use them to find k. So let's start with k1. That is equals to h f of x1 comma y1. And so this will be h x1 times x1 squared minus y1 squared. Replace the values. H is 0.5. x1, what was it? It was 1.5. Then 1.5 squared minus y1, which we have found to be 0.135819. Again, you square this. When you press in your calculator, you need to get the value of k1 as 1.673. 673, which is 1.665. Let's find k2. That is h times f of x1 plus h over 2, comma, y1 plus k1 over 2. And so this will give you h times x1 plus h over 2 times another x1 plus h over 2, and this is squared, minus y1 plus k1 over 2, this is also squared. When you press that, of course you need to substitute the values of x1, y1, k1, and h, which we have there already. When you do that and you press in your calculator, you need to get 1.851893. Proceed to find K3. So our K3 is given by h times f of x1 plus h over 2, comma, y1 plus k2 over 2. And so this is h into x1 plus h over 2. This is times x1 plus h over 2 squared minus y1 plus k2 over 2 squared. Substitute the value of x1, y1, h and k2. Press in your calculator. That will give you k3 is equals to 1.693 260. And finally, k4. From the definition, or simply from that table, we found h times f of x1 plus h, y1 minus 2k1 plus 9 over 4 k2 plus 3 over 4 k3. And so this should give us h times x1 plus h. This is multiplying another x1 plus h, and this is squared, minus y1 minus 2k1 plus 9 over 4 k2 plus 3 over 4 k3. This is squared. So when you press in your calculator, you need to get the value of k4 to be negative 0.95 1485. So that's what we have. Now let's use them to find k. So our k, based on that definition, we can say that therefore our k is equals to 1 over 5 into twice of k1. K1 is 1.673665 plus k3, which we got 1.693 260 plus twice of k4, which we have found negative 0.951485. And so press that in your calculator. That should give you 0.627524. Hence, y2 is equals to y1. Already we got the value of y1. Let me take you up. It was 0.135819 135819 plus the value of k which we have found 0.627. I can take you down. 627 524. When you press this in a calculator, you need to get 0.763343. 0.763343. So this is the value of y when x is equals to 2. So let's comment on this and write it is the same as writing y when x is 2, y2. And that's what you are required to find. So we have found it. Thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When you meet next time, we look at more problems involving numerical solution of ODEs. Bye-bye.